Hi there, welcome to my channel Mandu to Fandu. In this video, I'm going to discuss about the solution for finding the maximum path sum in a binary tree. Let's look at the problem description. We are given a root of a binary tree and we have to return the maximum path sum of any non-empty path present in that binary tree. That path does not need to pass through the root node. For example, it could be this path. Let's take a look at the example 1. So this tree has 3 nodes. There are 3 possible paths. One is from 2 to 1 and 1 to 3 or 2 to 3. So if for the first path 2 plus 1 3, for the second path 1 plus 3 4, for the third path 2 plus 1 plus 3 6. So the third path is having a highest path sum. So the output is 6. Let's take a look at the example 2. So in this there are 1, 2 and 3 and many more paths available. If we take this path and compute the path sum, it will be minus 1 plus 20 19 plus 7 26. If we take this path, it will be 35 minus 10 25 34. If we take this path, 25 plus 15 plus 20 35 plus 7 42. So this has the largest path sum. So the output is 42. The number of nodes in the tree is in the range from 1 to 30,000. The value of the node will be in the range from minus 1000 to 1000. Let's look at the approach to solve this problem. So we are given this input and the expected output is 42. So in this tree, the path starting from node 15 and ending at 7 is the path which has the largest path sum. 15 plus 20 35 plus 7 42. Okay. Basically we can perform the post order traversal on this binary tree, and whenever we return back to the parent node after processing the left and right subtrees, we have to compute the maximum path sum of the subtree which is rooted at that particular parent node. For example, after processing the node 15 and 7, when we come back to the 20 in the post order traversal, at that time we compute 4 possible maximum path sum. One is either the parent itself is the largest, or the parent value plus the left subtree's path sum forms the largest path, or the parent node's value plus the right child's maximum path sum forms the largest path, or the parent node with both left and right subtree forms the largest path sum. We have to get the maximum value among those 4 options and check with the global max path sum value. If the computed value is greater than the max path sum, then we update the max path sum. Let me explain the 4 possible path sum in detail. First, let's take a look at the case where the root node is the largest and the path sum include only the root node. For example, in this tree, so the root node value is 20 and left child is minus 10, right child is minus 30. If we consider only the root node's value as the path sum, we get 20. If we include the left child, 20 minus 10, we get 10 as the path sum, which is less than the 20. And if we include the right child, which is minus 30, so 20 minus 30 minus 10, which is less than the previously computed path sum 20. If we combine both left and right child to the root node, 20 minus 10 minus 30, it's finally it's minus 20. Path sum is minus 20, which is less than 20. So in this case, we will have to choose only the root node's value as the path sum. And let's take a look at the second case where the path sum includes the left subtrees path sum. in this tree, if we choose only the root node, the path sum value is 20. If we include with the left child, it will become 20 plus 18, 38, which is higher than the 20. So this is the largest path sum. If we include the right child, 20 minus 30, it will become minus 10. So which is less than the 38. And if we combine the both left and right child, in this case it will be minus 10, and then plus 18, it will be 8, which is less than 38. So we have to choose this path sum, which includes only the left child in this case. Let's take a look at the case where we include the right subtree in the path sum. So in this case, if we consider only the root, the path sum value is 20. If we include left child, 20 minus 30, we get the path sum value as minus 10, which is less than 20. If we include 25, the right child, we get 45. This is the largest path sum. If we include both of them, we get 15. 20 minus 30 minus 10 plus 25, it is 15, which is less than the 45. So we have to choose the path sum which include only the right child. Okay. So in the final case, both the left and right child's path sums included in the maximum path sum. So if we take 20, only the root node's value 20, then the path sum is 20. If we include the left child, it is 20 plus 10, 30. If we include the right child, 20 plus 15, 35. If we include both left and right child, 20 plus 10, 30 plus 15, 45. So in this case, we have to choose the path sum which include both the left and right child. So that's why I mentioned we have to choose one of those, the maximum value among the 4 cases. When we return back, so we have to pick up whichever is greater among these 2 children. We have to include that with the parent node's value and return that as the path sum to its parents. Let me explain why we have to include the largest child in the return value. For example, let's take this case. After processing this subtree, pick up the path sum which include both the left and right child. Okay. But if we return that 42 as the path sum back to the parent, we are including both these nodes. When we extend the path, the other end has 2 nodes. This end has only 1 node. But this is not the valid path. The path starts with 1 node and ends at 1 node, either one of them. For example, if we return the path sum with the largest child, in this case the left child, so this is the valid path. So this is the reason when we compute the maximum path, we consider both the left and right child, but when we return back, we have to include only the largest child. Okay, so that we get the valid path. This is invalid path. So finally, when we come back to the root node, we will be having the maximum path sum in this variable. Let's look at the flowchart. Input for this procedure is pointed to the root node and the max path sum variable. First we initialize the subtree max path sum variable. At the end of this procedure, this variable contains the maximum path sum in the subtree rooted at the current node. So first we check whether the root node is null. If so, we return 0. Otherwise, we make a recursive call to process the left subtree and assign the return value to the left sum variable. Same way we make a recursive call to process the right subtree and assign the return value to the right sum variable. So once we process the left and right subtree, when we come back to the parent node, at that time we have to compute the maximum path sum present in this current subtree, which has the current node as the root node. First we check whether the current node's value is greater than the subtree max path sum. If so, we update the subtree max path sum. The second case is combining the root node's value with the left subtree's path sum. If that is greater than the subtree max path sum, then we update the subtree max path sum. Next, we combining the root node's value with the right child's path sum and check whether that is greater than the so far computed subtree max path sum. In that case, we update the subtree max path sum. Then the current value of the subtree max path sum will be assigned to a variable called path sum with one child. So whenever we return back to the parent, we can include only one of the child in the path sum value, because we cannot have two nodes in one end. Path starts from one node and ends at one node. If we include both the left and right subtrees path sum, that means we are including both the nodes in one end. So that is not a valid path. So we include only one of the children's path sum along with the root node. So that's why we assign that value in the path sum with one child and return back to the caller. Then finally we check the last case wherein we combine both the root node's value with left and right subtrees path sum values. If all three values together is greater than the subtree max path sum computed so far, then we update the subtree max path sum. So there are four cases. One is only the root node, and a root node with the left subtrees path sum, root node with the right subtrees path sum, and root node with left and right subtrees path sum. So whichever is greater, the subtree max path sum will contain that value. Then finally we check whether the subtree max path sum is greater than the max path sum variable. This variable contains the maximum path sum rooted at the actual root node of the tree. Okay, so we compare the subtree max path sum with the max path sum, and we update the max path sum variable if it is greater than the older value of max path sum. Then finally we return the path sum with one child variable's value as the path sum of this subtree. Let's move on to coding. First I initialize the max path sum variable with minimum integer value, and then I call the helper function with the root node and the address of the max path sum variable, and then I return the max path sum after that helper function returns back. Next I'm implementing the helper function. First I initialize the subtree max path sum variable with to minimum integer value, and then I check whether the root node is null. If so, return 0 as the max path sum. Otherwise I make the recursive call with the left child and assign the return value to the left sum variable. Then I make another recursive call to process the right child and assign the return value to the right sum variable. After processing the left and right child, now I am going to process the parent. Here I compute the four possible max path sum values. The first case is only with the root value. The second case is root value with the left child's path sum, and the third case is the root node's value with the right child's path sum. The fourth case is the root node's value with both left and right child's path sum. So whichever is greater, that will be assigned to the subtree max path sum variable. So we'll check one in that order. First check First compare the subtree max path sum with the root node's value. If the root value is greater than the subtree's max path sum, then we update the subtree's max path sum. Then I add the left sum's value with the root node's value. If that sum is greater than the subtree max path sum, then update the subtree max path sum. Same thing for the right sum. And finally I combined the root node's value with both left and right child's path sum and check whether that value is greater than the subtree max path sum computed so far. If so, I updated the subtree max path sum variable with the new value. So these conditions are to update the max path sum variable. But when we return back to the parent, we have to include either one child's path sum, whichever is greater. For updating the value with both the left and right child's sum, I just created a new variable to store that intermediate value, so that that value will be returned back to the parent of the current node, and the with one child variable will be returned back to the parent of the current node. And then finally I check whether the current subtree's max path sum is greater than the overall max path sum. In that case, I updated the overall max path sum computed so far with the new value. Next, I am going to run the test cases. All the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. For this tree, the expected output is 42 because the path starting from node 15 and ending at 7 has a path sum 42, which is the largest among all other paths in the tree. So in the frame 1, when we call with the -10, we initialize the subtree max path sum to minimum integer value, and then because there is we call the helper function with the left child. So the frame 2 is formed. When we leave from that function, at that time the left sum and the right sums are 0 because this node do not have any left or right child, and the root is 9, and the subtree max path sum is 9 because we try to compute all the 4 cases. So the first case we update the subtree max path sum with the root node's value, which is 9. So that's why we see the 9 here. And then the max path sum is set with 9 because when we compare the subtree max path sum with the overall tree's max path sum, the current value is greater, so we update the max path sum with the value 9. So that's why we see the 9. Path sum with one child is updated with value 9, and then finally we return that value back to the parent -10. Similarly, we make a call to the right child with the 20 as the root node. Okay. we initialize the subtree max path sum to minimum integer value, and then we call the left child because this node has a left child. Okay, so the frame 3 is formed here. Okay, so when we enter, the max path sum is 9, the root node is 15, and the subtree max path sum is minimum integer value. When we leave this function, we have 15 as the path sum value because this is the only node. So only this condition is met, and we updated the subtree max path sum with value 15. Okay, and then the max path sum value is also will be updated to 15 because the previous value of the max path sum is 9 and the 15 is greater than 9, so we updated that also with 9. And then the path sum with one child is updated with 15. Okay, so when this node returns back, it returns 15 as the path sum, and then we call the helper function to process the right child. So here the root node is 7 and the current math path sum is 15 at the time of entering this function. When this function is returned, because this node do not have any left or right child, the left sum and the right sums are 0, and the subtree max path sum is initialized with 7, and the max path sum is 15 because this the current max path sum is 15, which is greater than the subtree max path sum. We are not updating anything here. And then the path sum with one child is returned, is updated with 7, and that value is returned back to the parent 20. Okay, so when the control comes back to 20, the right child returned 7, the left child returned 15. Okay, so that's what we are seeing here when we leave this node. So the these two nodes processed and the control comes back to the parent's helper function. There we get the left sum as 15 and the right sum as 7. First we compare the subtree max path sum with the root node's value, and because the root node's value is greater, we first update the subtree max path sum to 20. Then we combine with the left 35, and that value is greater than the previously computed subtree max sum, so 35 is updated. Then we add the root node's value with the right tree's path sum, and in this case we get 27. So the subtree will not be updated because it is lesser than the previously computed value 35. Okay, now the path sum with one child variable is assigned with the current subtree max path sum, which is 35. So that's why we are seeing here 35. And then finally we combine all the three nodes to check whether that is the path with the greatest sum. So in this case we get 42. Okay, and then we compare that value with the previously computed max path sum. Previously the max path sum was 15, and now 42 is greater than 15, so we are updating the max path sum with the value 42. So that's why we are seeing 42 here. And when we return the value with either one of the child, whichever is greater. In this case, left child, when we combine the root node with the left child value, we get 35. So we return that value as this entire subtree's max path sum value back to the original root node. When the control comes back to the left sum is returned as 9 and the right sum is returned as 35. Okay, and now again we do the same processing. First we check only with the root value. Minus 10 is greater than the minimum integer value, so we first update that value to minus 10. Then we combine that root node's value with the left sum. In this case, minus 10 plus 9 minus 1, so which is greater than minus 10. So we update the max path sum, subtree max path sum with minus 1. Then we combine the root node's value with the right sum. So minus 10 plus 35, we get 25. So which is greater than the previously computed subtree max path sum. So we set that to 25. And then the path sum with one child value will be initialized with 25, the current value. And then we combine the root node with the left child's path sum and the right child's path sum. So it's 44 minus 10, 34. So which is less than the previously computed 42. So we are not updating the max path sum. So when we return back to the max path sum function from here, when the function returns back to frame 0, at that time we return the 42 as the return value. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. So in this case, we call the helper function 5 times to process the 5 nodes in this tree. If there are n nodes, we call n number of times. So the time complexity of this procedure is order of n. And the space complexity is also order of n, because we are processing the tree using recursion, which utilizes a stack space. Maximum amount of stack space required is depending on the height of the tree. So if the tree is complete binary tree, then the space required is order of log n. But if the binary tree is a skewed tree, then the space complexity is order of n. Thanks for watching this video. Have a great day.